Okay, so if you're wanting to do factorial ANOVA or ANCOVA and use Julius.ai and get SPSS accurate results, this is the video for you. If you are in one of my classes and you've been watching this video series I've been doing, chances are you're pretty familiar at this point with a package called JMV. JMV is a package of code that allows us to get SPSS accurate results that's based on R. However, one of the challenges we've run into in these early days of working through all of the challenges of getting SPSS accurate results is that JMV is not a terribly well-known package, which means that Julius doesn't know a whole lot about how to write the code for it. And we've ended up with a lot of times where Julius runs into errors because it doesn't write the code right, and then it will fall back to vanilla R or vanilla Python, and I guess it shouldn't fall back to vanilla Python because we're using R. But when it does that, then we get non-accurate results. It can be really confusing whether what you're looking at is right or not. So I've come up with a new plan, a better plan. This does not require you to use JMV. There's very little advanced setup for you to do with this option, and I think you'll find that you get the right answers every time. So just a couple of things. First of all, you need to make sure that your runtime is set to R and not Python. I would recommend using Claude 3.7 Sonnet for your AI engine. You could use ChatGPT, but I find Claude to be more accurate in terms of writing the code, and you'll get results that look a lot more like mine. The numbers should all be the same, but with AI, with it being generative, it might create a different plot or graph for you where I might not even get a plot or graph. It's always a little bit different, but the numbers should be the same. One other quick thing, under settings, under customize Julius, I have this really interesting line of code, which I'm providing for you in the description of this video. You can just copy and paste it in. But if you're wondering what this is, SPSS uses a very specific calculation for skew that very few others use. Even the other main data analysis softwares use slightly different skew calculations. And so in order to make sure that we get exactly the right skew values, I've added this custom instruction, which should make sure that that happens for us every time. So I'm going to now go ahead and bring my file into this environment. So, you'll go to upload file. I just have been doing so much work with this that it was already in my files. So I just grabbed that. But you can just go to the upload button here and bring your file in as you would anything else. And then what I'm going to do, so what we have currently is a .sav file, and that's an SPSS file. So, and what happens is over time, that file will just fall away from the working memory of the app, and it will have to go back and get the data again. And it's a little slow because it has to read data that's not native to R. So what I want to do is go ahead and get this into an R data set. So there's a file type called RDS, which means R data set. And so what I'm going to do is I'm going to say ingest this data into an RDS file to use for the rest of this chat. And then I'm going to say save variable metadata as R attributes. So why am I saying that? Well, SPSS, as we've talked about before, has metadata. So if I go over here and look at whatever this data set is that I have open in variable view, all of this information, the type of the variable, the measure, the values, all that is SPSS metadata. And this RDS, which is the most advanced R dataset file currently, does not have a metadata storage system. But what it does have is the ability to add any attributes that we want. So basically, it's very open-ended. So I'm telling Julius to save all that information, just save it as a custom attribute. So I'm going to go ahead and let it run that, and I'll pause the video and come back just as soon as it finishes with that. Okay, so we have our data set, and I could ask it, because it did save all of my metadata, so I could ask it to show me the variable labels in my data set. So for therapy type, I would see CBT, psychodynamic mindfulness, whatever, but I know it's there, so I'm going to keep on moving forward. And I'm going to just give it a little hint. I'm going to say, this is my main data set. Keep it open for this entire chat. So what I'm saying is, don't close it. Keep this data set open, because elsewise over time it will just let it fall away. And part of that is because this data set is, Julius is meant for you to be able to open multiple data sets, which is one of the reasons why it lets them decay. So I'm basically letting it know, hey, this session, this is our main data set. I want to keep it open. It's going to save me some time down the road. Okay, now we get to the actual data analysis. So I'm going to say run a report for missing versus valid cases. And I'll go ahead and pause and let it run that. Okay, I'm running into an issue here that happens sometimes with Julius. So it actually looped. It ran the same code a whole bunch of times and it got into a loop. So if that happens, you can just, like, if you keep seeing it looks like the same thing, even just like the code explanation here, it's the same explanation over and over and over and over again, then you can click stop. And I was getting ready to click stop and it stopped on its own, so I didn't have to. But I can look in this table here and see that I have 200 valid cases, no missing cases. So that's fantastic. And I do like that it gives me the percent missing, which SPSS doesn't do by default. So that's kind of cool. So now what I'm going to do is I'm going to calculate skew. I'm going to look at, well, actually, let's look for outliers first. So I'm going to say using SPSS-style IQR formula. So this is the formula that SPSS uses for outliers. Check for univariate outliers on continuous variables. Oh, you know what? Let's do it this way. Let's say check for outliers in depression score first by therapy type, then by therapist experience. So we'll go ahead and let it run that. I will pause the video and we'll come back as soon as it finishes calculating. Okay, so we're getting some output here. So for depression score by therapy type, it looks like there's one outlier case, and it is 5.6 is the score for depression. It is below the lower bound of 5.84. For psychodynamics, that was for CBT therapy. For psychodynamic therapy, there are 0 outliers. And for mindfulness, there are 2 outliers, 20.2 and 21. SPSS does not see these, although I've checked this math backwards and forwards, and this is correct. So I'll make sure the lab reflects either the SPSS answer or this, but I've double checked this. This is correct. And then by therapist experience, there's 0 outliers for novice and 0 outliers for experienced. And you can see here the dot notation of 2 outliers here on the bottom for mindfulness and 1 for CBT. Okay, so we've looked at that. Now we can look at skew. So we're going to say check univariate skew for continuous variables. And then I'm going to add another line. I do that by holding down Shift and pressing Enter. So that gives me a new line. If I just press Enter, it's going to go ahead and run this. So I want Shift Enter, and then I'm going to say, then check skew for depression score first by therapy type, then by therapist experience. And the reason I'm saying first by experience, and it doesn't matter which one I put first, therapy type or therapist experience. I'm basically just saying, if I said check skew for depression score by therapy type and therapist experience, it would break it into the smallest groups. I just want to see the main effect group. So by the therapy types and by therapist experience, not by therapy type by therapist experience, which would be a different thing. So I'm gonna go ahead and run this, and I'll unpause when we come back. Okay, so we get our univariate skewness for continuous variables. So for age, we have a skewness of 0.08. For, let's see, what's the next one? Anxiety, baseline anxiety, we get 0.266. And for depression score, we get negative 0.285. And these are the same values that you get in SPSS. Man, it took me a long time to get the right setting so that it gets exactly the right ones. And then we get some visualizations, and then it's going to give me skew by therapy type. So we have for CBT, negative 0.124, for psychodynamic, 0.131, and for mindfulness, negative 0.262. By therapist experience, novice is 0.229, and experienced is negative 0.2. So so there we go. That's what we needed. So now what we can do is we can go ahead and move into the ANOVA itself. Oh, you know what we didn't look at was case split. So let's go ahead and just look at that really quickly. Run a report for case split. And I'll go ahead and pause while it does that. Okay, we're getting some output here. So let's go take a look and see what we have. So for gender distribution, you can see the breakdown here, 44%, 45.5%, and 10.5%. And then you have your case counts, and you get a little graph here. And then you have the same thing here, therapy distribution, 45%, 25%, and 30%. And let's see, experience distribution, 45.5% and 54.5%. And then again, you get the raw counts here. So yeah, so that's great. Let's go ahead and move forward to doing the factorial ANOVA and running the assumptions for that. But here's the good news. Again, in previous videos, I've tried to show you how to use JMV, and I had my own challenges with that, just getting it to run the right way. So instead, what I've done is I've created this tool on my website, drjonathanhoover.com/JuliusPrompt. And what this is going to do, I'm going to fill in some blanks, and it's going to give me a prompt to give Julius that should give me the right results every time. So my dependent variable is depression score. My independent variables are therapy type and therapist experience. I'm not going to enter the covariate yet. We'll do that when we get to ANCOVA. For ANOVA library, I'm going to set this to AFEX or AFEX. And then let's see, is there anything else I want to change? No, everything is here. So I've got my Levine's test, I've got my post hoc, all that stuff is figured out there. So I'm going to go ahead and copy to the clipboard this prompt for Julius, and I'm going to go over here and just paste it in. And it should give me all of the information that I need. So basically, think of this like SPSS is almost like your favorite fast food restaurant. Like I love Chick-fil-A. It's kind of like that. It's very reliable. You're always going to get the same thing. And, many of us love what we get from SPSS, like you love what you get from your favorite fast food restaurant. Julius is more like a really well-trained chef. Julius can make for you what SPSS makes for you, but Julius has a much larger repertoire, and you have to give it very specific instructions in order to get the thing that you want. And that's what we're doing here is it's not because Julius isn't good at what Julius does, it's that we have to give it instructions to know how to get that very specific product that we're used to getting with SPSS. So I'll pause this while it goes through the mini steps that we just asked it to do. Okay, it looks like we're starting to get our final output here. It takes a couple minutes because it has to work through all the steps that we gave it. So yeah, let's just take a look here. So the first thing we have is there is a main effect for therapy type. F with 2 and 194 equals 36.08. P equals less than 0.001, and partial eta squared is 0.271. There is a main effect for therapist experience. F and 194 is 29.35, P less than 0.001. By the way, we could check these really quickly just so you can, for the sake of having confidence, I could run this really fast in SPSS just to show you. So if I make sure that all of this is set as it should be. So you see here that our tested between subjects effects here. So we have 36.08, 29.348, and 10.885. So if I go to Julius here, I see I have 36.08, 29.35. Is that what we had? 29.3? Oh yeah, if you round it. And then 10.89 for our interaction. So yeah, and it looks like maybe did it not round it exactly the same way? Let me double check with SPSS. 10.8, yeah, 10.89, but it looks like it didn't round it the same way, but it would be accepted on the lab. But basically you're getting the same answer for these three across. So your main effect, interaction effect. And then for our post hocs, we can see that CBT versus psychodynamic is statistically significant. This is a main effect post hoc, so a pairwise for a main effect. CBT versus mindfulness is also significant, and psychodynamic versus mindfulness is significant. Here you would see that in SPSS if you went down to pairwise comparisons for your different therapy types, and you can see that all of these are significantly different from each other. So let me go back here. Yes. Okay. And then therapist main effect, you have novice versus experienced is 4.49, p less than 0.001. So you can see that here as well. That if I go down here, you have, let's see, where is it at? Yeah, 4.49, p less than 0.001. So you can see we're getting the same values, thank goodness. And then once we do that, then we can break it down even further. So for novice therapists, CBT versus psychodynamic is not significant. But for novice therapists, CBT versus mindfulness is. Psychodynamic versus mindfulness is not significant. For experienced therapists, all three are significant. CBT versus psychodynamic, CBT versus mindfulness, and psychodynamic versus mindfulness. Then we get a plot. And yeah, a few visualizations. And basically our key findings are mindfulness therapy is associated with the highest depression scores. Experienced therapists generally achieve lower depression scores than novice therapists. You can just see it's basically just walking us through the findings, which is where it really shines, where this really shines. And that's what I would need, right, for my review of the factorial ANOVA. If I was doing that in a lab, or maybe you're watching this for some other assignment, or you're doing actual research, that would be the majority of what I would need. And then I could go even further and look at interaction effects even at a deeper level, or I could look at more visualizations. Obviously, it's offering to do profile plots and density plots and heat maps, so I could do that. So now I want to show you what we would do if we were going to do this as an ANCOVA. So I'm going to go back to my tool here. I'm going to leave everything as I've set it up, but under covariate, I'm going to say age. So I want to now add age, and I'm going to click test homogeneity of regression slopes, which is another assumption that we have to test. And here, this is actually, I think, easier than SPSS because basically we're going to just give it the information on how to run this test. I don't have to set up a custom model because all that's in the code that I've generated behind the scenes. I'm going to go ahead and pause this while it runs. Okay, so I found an error as I ran this, and I will fix it with my code. Before I ever post this, I will fix this with my code. But under where I'm giving it instructions here from my site to run homogeneity of variance, or homogeneity of regression slopes test. So if you look through what I'm actually saying here in my prompt, I'm saying run factorial ANCOVA, dependent variables, independent variables covariate, and then I'm saying here's the settings that we're going to use, but then I'm going to say before running it, test homogeneity of regression slopes, and where we have an issue here is I need to tell it here in parentheses, and this will be added for you. You don't have to do this. I'll make sure that my website does this for you. Do not run Levine's for this step, because you're actually going to have problems if it tries to run a homogeneity of variance test with the homogeneity of regression slopes strategy that we're using here. So in SPSS, when we test homogeneity of regression slopes, what we do is we build a custom model. So we go over here to Analyze, General Linear Model Univariate, and once we add that covariate, we're going to go in and create a custom model by going Model, Build Terms. We're going to make sure that each of our main effects, including the covariate, are over here by themselves, and then we're going to add one interaction term. There's a problem with this, though. And that is that we're doing something that some people refer to as a top-heavy model or an unbalanced model, where we have a three-way interaction here, but no two-way interactions. There really should be the two-way interactions beneath it. So therapy type by therapist experience, therapy type by age, therapist experience by therapy type, therapist experience by age. That really should be part of this, but the problem is there are issues of doing that. So there's more than you want to know. I did a lot of studying on that this week as I was trying to deal with the fact that while SPSS will let you do this, SPSS will let you do a three-way interaction with no two ways underneath it, R won't, because it's in many places considered bad statistical practice. And so what we typically do is just look at that interaction line to see if it is statistically significant. In this case, it is. However, there are a lot of people that will, from the research I've done this week, will doubt whether or not this is actually a finding we should use. What I'm using over here now with R and with Julius is a much more vetted method for doing this. And so I'll show you here in a second what we're doing. So what we're doing here to test homogeneity of regression slopes is we're fitting a model that includes age as a covariate, and we're fitting a model that includes age as an interaction term. And then we're actually running an ANOVA on those two models. And if that ANOVA is significant, then we have a problem. If the ANOVA is not significant, then we can assume that our homogeneity of regression slopes is met, and we can move forward. And so that is what we are testing at the moment here. I'll go ahead and pause while it continues to run. Okay, so it looks like we're getting our full output, which is always great because it takes a minute for it to do this. So it tested the homogeneity of regression slopes. And here you can see our p-value is 0.721, very different than what we get here with SPSS. And frankly, I trust, after all the research I did this week, I trust this much more. So I believe that I'm much more comfortable with F with 5 and 188 equals 0.721, assumption met. And then so we can then move forward. So here are our full ANCOVA results. So we can see that, and here you can see this is scientific notation with negative exponents. So these are tiny, tiny, tiny values, less than 0.001 for sure. And here you can also see that we have 3 asterisks here. So if we use our little legend here, we can see that it's less than 0.001. It's significant at the 0.001 level. So we can see that therapy type is significant, and therapist experience is significant, and therapy type by therapist experience is significant. And we see our values are 35.25, 29.25, and 10.445. So I can actually go over here and run this really quick and show you. So if I go to general linear model, and I go back to full factorial, so this is for the full ANCOVA, you can see that what we get here is 32.25, 29.255, and again, you're seeing this is what we're seeing: 35.25, 29.255, and then 10.445, which will be our interaction. So you see all of those are there. The one thing we have to look for is the actual covariate term, which generally has given me with this code. I may have to go looking for it. So I see here that my partial eta squared for age is very small, but I still would like to see the actual covariate effect. So I may have to ask for that. Like I said, when I've run this code so far, it's always given it to me. And this is the one thing that you may run into from time to time, is that something you're expecting to see, like the covariate here. Oh wait, it is here. How did I miss it? It was right here on top of the table the whole time. I was really surprised because I expected to see it. There it is. Age, F with 1 and 193 is 0.068 or 0.07, and our significance, so this is probability of F, so this is what your p-value is 0.79, so not significant. And we have our descriptive statistics. These are our raw means. And then we have our post hocs that show us that CBT versus mindfulness, when we're using the covariate, is still statistically significant. CBT versus psychodynamic. And then CBT versus mindfulness, significant, p less than 0.001. Psychodynamic versus mindfulness, significant. And then I can look at just experience here, also significant at less than 0.001. And then we can look at simple effects and say that for novice therapists, CBT, or I guess maybe we're saying that the subject's therapist is a novice. The difference between CBT and psychodynamic is not significant, p of 1.00, so definitely not significant. For a novice, CBT versus mindfulness, 0.02, so that would be significant. Psychodynamic versus mindfulness, 0.17, not significant. And then for experienced, CBT versus psychodynamic, significant at p less than 0.001. CBT versus mindfulness, significant at p less than 0.001, and then psychodynamic versus mindfulness is 0.002. So then we could look at simple effects of therapist experience at each level of therapy type. So we could then look at novice versus experienced for CBT, p less than 0.001. We could look at novice versus experienced for psychodynamic, is 0.05 basically. And then for mindfulness, novice versus experienced is not significant, 0.50. And then I could look at some visualizations, but at the end of the day, that is our ANCOVA. Now I could ask for, if you're one of my students and you're watching this, you're going to have to provide a table with adjusted and unadjusted means. So I can just ask for that. Provide a table with adjusted and unadjusted group means. And I will go ahead and pause while it does that. Okay, so here we go. So for CBT novice, our unadjusted mean is 30.56 and our adjusted mean is 30.55. So, you can just go through each line. I would like to see, let me see. So those are our by interaction group. I want to say provide a table of adjusted and unadjusted group means for main effects. So by saying that, what I'm saying is I just want to see the CBT versus psychodynamic versus whatever. And it would have been okay if they'd given me like a total in this table so I could actually see what total CBT is, total psychodynamic is, whatever, but it gave me sort of the further breakdown. So I need to ask it for the higher level variables. So I'll pause while it does that. Okay, and here we go. So basically I get the two other tables that I need. So for CBT total, the unadjusted mean is 25.5 and the adjusted mean is 25.92. And by the way, you would see this. So if you went to your descriptive statistics, where is it? Descriptive statistics. What were we just looking at? Was it CBT? Yes, for CBT, my unadjusted mean total 25.49 or 25.50. So we'll double check that. Yeah, 25.50. And then my adjusted mean, where would I find that? I find that in my estimates table. So I'm going to look for a table called estimates. Where is it at? Apparently when I ran that, I did not click on estimates. So let's do it. Univariate, I must have not done the EM means. So we'll fix that real quick. Okay, so now I should be able to find estimates for CBT 25.915, and here we get 25.92, which is just rounded version of that. So we have our mean and unadjusted and adjusted, and then we have our unadjusted and adjusted for novice and experienced. So what do we have? We have our main effects here, our main variables. This is for therapy type, and this is for therapist experience. And then if I go up here to the table it gave me at first, I have therapy type by therapist experience, which is exactly what I need. So, and then one last word, if you're in one of my classes, I'm going to ask that you just go ahead and click on those three dots when you're done with a lab, click download and save as a Word doc, and don't necessarily send it to me unless I ask for it, but I may need to see what you did in case you get an answer wrong, but you were doing all the right things and something didn't work out with the AI engine. So send that to me if I ask for it. Just make sure you keep it around and name it something that you can find. But I hope this has been helpful for you. I will make that one adjustment to the codes, which should hopefully fix the issue with it trying to do Levene's as part of the homogeneity regression slopes. But the goal of providing this tool is to take all of those, as I said, it's like that chef that needs to know how to make that fast food meal that you love the way that the fast food restaurant always does it. There's all these settings here that are common to SPSS that hopefully by doing this, you can just generate that and not have to think about it. But the reason I built the tool this way is that if you did need to change something, so maybe you needed to change from sum of squares 3 to sum of squares 1 or 2, and you have a reason for it, you could easily go in here and change one of these boxes and get a different result. So hopefully this is helpful, and please let me know if you have any questions.